as you go through these types of problems, the whole point of showing you guys how to graph things manually prior to doing anything calculatorable, makes sense to me, is that you can identify what format you're in. So if you look at this problem here, what format is this in? The second one, the vertex form. Okay, this is in vertex form. By looking at it, you have a positive A value, which means it's going to be up like a cup. And you know that your vertex is then located at 90.2 and 51.3. And it does this. Ish. Okay. From there, the problem was just asking you, what is this doing between x values of 50 and 150? Well, if your x value for your vertex is at 90.2, where's 50 in relationship to that? Left or right? Left. Well, about here-ish. Where's 150 in relation to it? On the right of it. Here-ish. What's happening to the graph between here and here? Decreases, hits a minimum, it increases. Go to the next problem. That's all you have to do. The idea behind that is understanding that you're written in that format. You don't have to math it. All you have to do is just do, oh wait, vertex form tells me my vertex is located there. Sorry. So you'll notice that you're near the vertex. You are decreasing to get the vertex, and you're increasing up there. And then what does that mean in terms of the energy? As you're slowing down, or as you're approaching your energy level of whatever the x, your walking speed, as your walking speed gets closer to 90.2, you're decreasing, and then as your walking speed increases, you're increasing your caloric outtake. That's all it means. Okay? What's that? Take it with a grain of salt. And some of these things you have to take with a grain of salt. And I don't mean because your blood pressure goes up because you're taking salt. The woodland jumping mouse can hop surprisingly long distances, given its small size. A relatively long hop can be modeled by the following. Bless you. Negative 2/9 x times the quantity x minus 6. That's pretty darn close to being into what format? You're right. Which one is that? Nope. Vertex. It's very close to being in the vertex form. Watch what happens. If you distribute it in, you get negative 2/9 x squared plus 12/9, which is 4/3 x. What's your C value here? 0. So when the woodland mouse, relatively small for its size, jumps surprisingly far distances, where is this woodland mouse jumping from? The ground. And then it goes up, and it comes down. Okay? Now, if it's starting at 0 because there is no C value here, can't I just figure out what the axis of symmetry is and double it, tell me how far it jumped? Good. So all we do is take our opposite of B over 2A, so opposite of B over 2A. Well, if I double negative 2/9, I get negative 4/9. Complex fraction. When you have fraction divided by a fraction, you multiply by its reciprocal. So you get 4/3, negative 4/3, excuse me, times negative 9/4, otherwise known as 3. So this woodland mouse, small in its stature, halfway through its jump has reached a horizontal distance of 3 feet, which means it lands how far out? 6 feet, okay? So if it jumps out 3 feet, we know that the axis of symmetry has to occur at its vertex, which happens to be called a maximum. What's 3 squared? And you get how high up in there this woodland mouse jumped. 2 feet. So it jumps surprisingly long distances for its size, but as it's going, it starts at 0, jumps up to 2 feet, and it lands 6 feet away. Yes, sir. We know that it started at 0, okay? And the reason why we knew it started at 0 because there's no C value as we go out there. So if you know that you're halfway starting at 0, what goes up must come down, right? So you have a 0 starting here, and something else happens here. We can figure out what's halfway in between. It has to be the axis of symmetry because it starts at 0. If there was a plus C or something thrown in there, we couldn't do the axis of symmetry. Then we'd have to use our calculator to figure out the maximum value. So here, knowing we start at 0, we can just find the axis of symmetry. There's your halfway point. If halfway is 3 feet, double it, you're at 6. Because the distance between both of them has to be the same. Does that make sense? No, I think that's just dumb luck that it was there. But actually, yes, it's a 0 because you're right, this is intercept form 0 and 6. I never thought of that. Who said intercept form earlier? I didn't even think of that for intercept. You're right, it is intercept form. I didn't think of that being intercept form because I forgot that the A value was thrown there. Yes, you could have done intercept form because you have 0 and 6. What's halfway between? 3 done. I didn't think of that. Nice job. What's 3 squared? The 3. Yes, sir. Because this generated our maximum value of 3. Yes, sir. What's halfway between 0 and 6? Axis of symmetry. Opposite of B over 2A. Opposite of B was 4/3, so it's negative 4/3. 2A, I doubled negative 2/9. Or in this case here, I didn't realize this, I completely overlooked it. This is intercept form. What are your zeros? 0, 6. What's halfway between 0 and 6? 3. Same thing. I didn't even think of that. I've been doing this problem for 7 years, 8 years, and I never even thought it was intercept form. I always go, yes? Yep. Yep, I'm just substituting back in to get my Y value. That's what we're doing. Yeah, you can do a hard reset. You remember how we did that before? If you ever want to do your hard reset, it was a second plus sign 712. It's second plus 712, and then second plus 722. That does a full hard reset on everything. If like everything's getting all screwed up, you have no idea what you're doing, hard reset, and then just go on from there. Okay. So there's your woodland mouse. Surprisingly jumps far. Automobiles. Not it. Engine torque. This one is written in what form? Standard form. So here they're saying the X is the engine speed in RPMs, and find the engine speed that maximizes torque. So if you're thinking about it, here you've got a y-intercept because you have a C value. Okay. So what's happening is we need to figure out the maximum value. Well, you can do this a couple of different ways. We still know that your axis of symmetry works through it. You can do the opposite of V over 2A. Do it alphabetically, mathematically that way. Or if you throw it in the calculator, you can find the maximum. Okay. When you do that, if you use the calculator, it was what, negative 3.75x squared. Oh, thank you. And if we graph that, it's not showing up in my window because I have it set from a problem from earlier. I just have to start looking for it. So if I'm doing this, I know that I'm looking for something that's to the right of 0. And I know that I have a starting point of my graph at 38.8. So maybe I'll raise my RPMs up to 80. Because I don't think it's going to run more than 8,000 RPMs. VTech engaged. X minimum 0, X maximum, maybe we'll just do, I don't know, 50. Well, I think it's times 100 though on here, wasn't it? Because if you ever look at a car, it says RPM times 1,000. Yeah. Oops. Too far out, not high up enough. See how you can figure that out real quick? We're too far out to the right, but not high up enough, so I'm going to change it again. I'm going to bring back in the Y maximum. We'll go to maybe 25, just cutting it in half. And then go our Y max, maybe go up, go up to 75. Oh, well, it's better. Just in case I'm not at the very peak there, I might just raise it up to 85 just to double check, and then I'll just go from there. And this is kind of what happens when you're doing these problems. If you're trying to figure out where it occurs, it might take a minute or two to adjust your window. Okay? If you get the error message, like invalid dim, invalid dimension, it says, that means your X and your Y, your X minimum is larger than your X maximum, or your Y minimum is larger than your Y max. You have something flipped by mistake, or you put if it has an error message on the graph, it might be you use the minus symbol, not the negative one. It's another common mistake. So you just hit second, calculate, and now we're looking at a maximum, option 4. Left boundary, I'm way out here negative, so I have to hit left a whole bunch of times. It's a good day, isn't it? Oh, there we are. All right, so I hit enter. Yes, sir. I can't hear you. What? What? Yes, as long as it's to the left, because it should get. You want to get as close as you can to most of it, but if you're off by a couple hundreds, you're pretty darn close. And a lot of that depends on how your window gets set, as well as where you place it. So it can be pretty close. So this tells me at an X value of 3.09, my maximum. So my X value is 3.09, my Y value is 74.68, which means the engine, if it's turning 3,000, basically 3,100 RPM, the maximum torque in my engine is 74.68 foot-pounds. Not a lot of torque for that much RPM. Sounds like a small 4-cylinder diesel engine, to be honest with you. Cars are fine. No, it's just, it happens. One half ties one pattern, the other half is the other. Okay. Then the last one on that page is the football field. All fields, if they're done correctly, they have what's called a crown to them, and that crown allows the runoff for rainwater, and it's ever so slightly sloped, so that way you don't notice it, because you wouldn't want to. Yeah. Just think of running up there and go, oh God bless it, my calves are killing me. You know, think of that leg workout. You know, you wouldn't want that. But yeah, this is a very slight thing. And if you think about when you're looking at this problem, just the format of it, what format is this problem given us? What equation is it given? It's vertex, right? So vertex, it's saying that the actual field is shaped like a parabola. This is measured in feet, okay? So if you're in vertex form, let's draw this a little bit larger. What's the vertex there? 80 and 1.5. Man, you guys read so well. This is in feet, ladies and gentlemen. So if you think about it, from one sideline to the middle of the field, it only raises up 1.5 feet. And it takes 80 feet to rise that. Okay? So if you want to do slow, you can do rise over run if you really want to get fancy. You guys are so how wide is the field? 160. That's it. Did you have to map that? And that's the idea. Sometimes if you start to understand the formatting that you're given, less mapping you have to do.
What does it mean?
How wide is it? What is that? That's the maximum, right?
Yeah.
So what's your axis of symmetry is at 80.
I found that, but I thought it meant with the, I don't know.
So from 0 to 80 is how many feet? How many feet is this to here then? Another 80, so it's how wide?
They need to reword that better.
Okay. Where are the rest of my? Oops. On the back page, then, guys, back page. I did like. Did you guys get a weird numbers for the stereo?
Yes, I hated that.
Good. You were. All right. I mean, I'm sorry for saying good that you hated it. I wanted you guys to have a problem that doesn't line up cleanly. You have a calculator. You shouldn't have. I hate to say this. You're gonna have a lot of fractions. You're gonna have lots. All right, here we go, guys. Again, when you are doing sales figure style problems, it is kind of forcing you into intercept form. It says that you sell 20 stereos at 80 bucks. Those are your first two spots that you would foil. 20 stereos at $80. They believe that for each decrease in $5 in price, which means the 5 goes with the 20 or with the 80, goes with the 80. Every decrease in $5, 6 more stereos are sold. Okay, so if I decrease it 5 times, however many times, I will increase 6 times my sales. Okay. This gives us now zeros. Because what we do is we're going to figure out what are our zeros. Well, did you know that the calculator will allow you to put this directly into it like this? So you can throw it in, if you start getting weird numbers and you're worried about it, if I'm allowing to use a calculator, use a calculator. But if not, you have to still know how to do this. So you have zeros here at negative 10/3. And then, what is that? 16? Is that right? 16 and negative 10/3, I believe? Okay. So we have to figure out what's halfway between them. No decimals. Your fractions. So the halfway spot, excuse me. Nice. You had 19/3 for the axis of symmetry for x. Okay? And it's okay that you get a fractional amount. That's my x value. So if I take that 19/3 and I substitute into each of my equations, which means that if I take 19/3 and I multiply it by 5, and I decrease that was the decrease one, right? And I take 80, subtract it, that tells me if I sell my stereos for $48.33, I will sell how many stereos? If you substitute back over, what do you get? 38, you sell 58 stereos, is that right? Is that right? 58 stereos?
Yes.
You sell 58 stereos. So it's okay that you have a sales price that's decimal, because aren't most things when you buy it, don't they have pennies to it? It's fine. It's okay. It's okay. So don't freak out and don't get upset and angry if you see a fraction and or decimal. You'll be fine. Okay. Last one in here. Rental company, they manage an office building. They have 16 offices. They'll rent all 16 at $1,000. If the rent increases $200, they rent one less office. Again, super easy. This is one I would definitely want to use my calculator because it's weird. So you have 1,000 for 16, and then it was every $200 increase, you subtract one office. Now, they wanted you guys to have a monthly revenue that was equal to $20,800 every month. When they give you a desired income, a desired revenue, this is when you don't want to do your axis of symmetry, you don't have to factor in all other stuff. This is when you want to go right to the calculator and use the table. Okay? So if I put this in my calculator just as it's written, parentheses 1,000 plus 200 x, close open, 16 minus x. If I put it in the calculator just like that, and I go to my table, I'm looking for where this graph equals 20,800. So you hit second table. And notice it occurs in two spots. Everybody see that? It occurs that if I increase the price 3 times, or if I increase the price 8 times. Sorry. If I increase the price 3 times, then I'm selling it for $1,600 plus 600, so it'll be $2,200. Yes, sir. I didn't use the calculator because the fractional mark doesn't show up as clean. That's why I did it by hand. What? Like I just said a minute ago, anytime they give you a desirable income or a desirable revenue that you're looking for, this is the easiest way to do it. Because what I'm saying here is that we increase the price 3 times, so you increase the price 3 times to 200. So you get 600 plus the 1,600 was 2,100. That's where I got that. And that meant I'm getting 3 less. I have 13 units being rented out at that price. Also, if I increase the price 8 times 200, that'd be what? 16 plus 16 would be, if I'm renting it for $3,200, there are still going to be 8 SAPs that'll pay for it. So I could either try my best and get 8 people to rent it out, or try it and just get 13 people to rent it out. That's all that means. There's 2 possible ways to get that income. I just thought it was easier to do it that way when you have a table. Whatever you have desirable income, easiest way to do it. Okay? Not terrible on those? Okay. What I'm trying to show you is that sometimes you don't have to. Sometimes it's quick without. And that's the idea that we remember those steps. Hey guys, hey, this is a great question. Sponsors are saying, hey, is it okay if I did all these things by with the calculator? Absolutely. But what I'm trying to get at here is think about time. Time constraints on quizzes and or tests. You have all the time in the world to be able to put everything into the calculator. Sometimes you have to sit there and read through the problems themselves and realize that, oh, I'm not a knucklehead. I recognize, I'm not implying anymore, so don't think that I'm implying that, or am I? I would make sure that you recognize the format. You understand the format that you're given. Sometimes mathing is quicker. So let me talk about a few of these. Here's the practice. So the only other style ones that we have done a bunch of are ones where they're giving you what's called initial velocity. I was telling first hour with this, and I'm not going to have you guys try to create and come up with your own initial velocity formulas. That's for physics. For us, we'll just say you guys will have something in front of you. Okay? But I do want to know, I do want to make sure that we understand what these pictures look like, what they're talking about when you're looking at them in a calculator, and that way you can see where all this stuff is coming from. Because the first 5 over there, those are all projectiles. For example, if I'm looking at the third one, you got the formula, height is negative 16t squared plus the 48t plus 160. It gives the height of an object thrown from ability 160 feet in the air with an initial speed of 48 feet per second, where t is measured in seconds. Find the time for the object to hit the ground, and find the maximum height of the object. So, visually, what it... Sorry. Oh, yeah. Anyway, so guys, remember, there's building. Buildings are generally connected to the ground via a foundation. In case you didn't know that. It says the object is being thrown from the top of the building. You can literally go, but it's got to go down. So there's an object being thrown from the top of the building, and they're throwing it at an initial velocity upward. And what goes up must come down. Now, this value of t is representing time in seconds. Notice that it's in the formula ax squared bx plus c, so t is taking control of the x-axis, right? H is being taking control of the height, the y-axis. So you know you're starting at 160 feet up. When they throw it, it goes up and hits there. Now, if you throw that in the calculator, if you calculate your maximum, what's that going to find? What's the maximum going to find there for you? The maximum height. Now, in that ordered pair, is it going to be the x or the y? Is the height? The y. The y value is represented by the height. Okay. Now, when you're following this parabola, then, what will that be found as? 0. Very good. The 0. Where did the object hit the ground? Remember, we threw the object. Remember the sound effect. So the other day when I recorded for them, I went down to Huntley. They all decided they're all listening to the video at the same time, and all of a sudden they hear me going, ah! And then they realized that they can replay it at very slow speed. It was. It was something. So be careful what you say. They may or may not repeat it on a loop. So these are a lot of these guys. A lot of these first ones are an exercise in adjusting windows again. My window was set up here from a minute ago. I'm going to shorten the x value, but I know I have to raise my y value because I know the height started at 160. So I'm going to go up to maybe 200 to see what happens. But I'm going to bring this into about 10 for the x. See 200, see what happens. Try it again. Hey, that was a good guess. So threw the object up in the air and let gravity take over. Hit your second calculate. Get a maximum first. It doesn't matter which one you choose first. Son of a Billy Goat. I knew I should have chose 0 first. It's nice to have a calculator that doesn't have to do this all the time. Anyway, so there's the left boundary. Move over to the right boundary. The maximum height that it reaches, 196 feet in the air. So you basically threw it 36 feet up in the air. And then from there, calculate a 0. And it took 5 seconds for it to hit the ground. Well, you take something in your arm, you reach back, you step and throw. You give it an initial velocity. And then gravity is the negative 16 t squared. It's a the ones at the bottom, just a reminder, you're going to maximize area. Means you have to remember, how do you find the area of a triangle? 1/2 base times height. Perimeter of a rectangle. So twice the base. You're right, Adam. Twice the height, length, width, however you want to call it. And then lastly, area of the rectangle. You'll utilize some of those formulas in there. And you're just basically throwing some buttons.
Give those a shot, and I think we're kind of at the end of those. And then tomorrow we will start with completing the square. We may or may not do a little bit of the quadratic stuff tomorrow. I think I'll hold off on quadratic till Monday. But we'll play a different place.